So we're going to derive the quadratic formula. I recommend that you watch the previous video on completing the square, because in order to derive the quadratic formula, we basically just need to complete the square on what's called the general quadratic. So let's for a moment think that we've got the general quadratic, which has this form: y equals ax squared plus bx plus c. All right, what we want to do is we want to take out a as a factor first. And now let's think about that for a second. The reason we want to do that is because we need x squared in order to complete the square. If you recall from the previous video, you have to have an x squared sort of tile to complete your square, and you'll see that in a moment. So you have to complete this, you have to complete the square, and that means you need to take out a as a factor. So let's take a out as a factor of this entire thing. So a comes out the front. So this becomes b on a x plus c on a. So just taking it out as a factor of every term, right? Okay, so what you're going to get is this. We're going to start to complete our square just like we've done before. So we're going to take our x squared sort of tile or square. And then what we're going to do is we are going to create these two extra parts of our square. So let's think. This is b on ax. So what that means is both of these green parts, this part and this part, when we add them together, they have to equal b on a x. Now that's a bit confusing, but that must mean that the side length must be half of b on a, which is b on 2a, because b on 2a plus b on 2a is b on a. Okay, so that can be a bit confusing, but basically, if we half something, if we take some number and we half it and then add them back together, we get back to the original number. So we're halving b on a to give us b on 2a, as it's going to be this side length here, which means that these areas are b on 2a x, because we know that length there is x, and this length here is b on 2a. So this total green area here is b on 2ax, and similarly over here. Okay, the next part is that we've got this c on a that's just coming along for the ride at the moment. So we're just going to put that down. Okay, the next thing we're going to do is we're going to work out what needs to go here. And I'm hoping you can already start to guess what needs to go here. You know the side lengths of the square. You know that this side length here is b on 2a, just from how we broke things up. And you know this length is b on 2a. So I would hope you would agree that this section in here must be b squared on 4a squared. If we take b on 2a, multiply by b on 2a, we get b squared on 4a squared. Okay, but that would mean we've changed the equation. So what we need to do is we need to adjust for that. We can't just randomly add b squared on 4a squared. We need to subtract b squared on 4a squared. So let's just think of this as being the opposite. These two tiles would cancel out because one's positive and one's negative. So really we haven't added anything. Everything is still balanced because we add b squared on 4a squared and we subtract b squared on 4a squared. Okay, and we can't forget about this term here, which was c on a. So we actually have this c on a tile here as well. Okay, and then what we need to do is we need to factorize now. So now we think to ourselves, let's just look at this first part, these first three terms. Well, those first three terms make up the main part of the square, right? So you've got x squared plus bax plus b squared on 4a squared. So we can factorize that. And the way we're going to factorize it is, well, to get all those terms, we would multiply x plus b on 2a by x plus b on 2a. So this part here, these three terms factorize nicely to x plus b on 2a all squared. Okay, then we can't forget to bring down the minus b squared on 4a squared and plus c on a. But it's good because we've almost completed the square now. Okay. The next thing we're going to do is actually now we're going to start to solve for x, which might seem challenging with all these pronumerals, but it's actually not too bad. What we're going to do is we're going to set the y value equal to 0. So we're going to essentially find x-intercepts. To find x-intercepts, you let y equal 0. So what we're going to do is, we're going to set y equals 0, and then we're going to try and solve for x. So the first thing we can do is we've got this factor of a out the front. So thankfully, if we divide everything by a, then that just drops out because 0 divided by a is 0. So that just divides through and that cancels out essentially. Okay, then we've still got all this other stuff that was inside the square brackets. Okay, the first thing you might notice is I've actually changed it a little bit. This C on A, we've got two fractions here, so we want to get them with common denominators. So we've got 4a squared here, and we've just got an a here. So I need to make that a 4a squared. So that must mean I need to multiply by top and bottom by 4a. So that's why on the top I've put 4a, and on the bottom I've put 4a squared, because now there's common denominators. Okay, so we get this, but just sort of all we've done is change that. Okay, I'm going to add to try and get x on its own now, yeah? I'm going to add b squared on 4a squared to the other side. So that just moves to the right-hand side. I'm going to add b squared on 4a squared to the left-hand side and to the right-hand side. So we get b squared on 4a squared on the left. And then I'm going to subtract this term here, which is 4ac on 4a squared from both sides. So we get this. Okay, the whole point was that these are now common denominators. So now we can actually write this as b squared minus 4ac on all over 4a squared. And that equals all this business still. Okay, we're almost there. We've almost found x. What we need to do now is we need to take the square root of both sides. And remember, when you take the square root of something, you need to take plus or minus. So what that's going to look like is this. I'm going to take plus or minus the square root of the left-hand side. So we do the same thing to both sides. We take the square root of both sides, and then we're left with x plus b on 2a on the right-hand side. And then we get this, because remember, when we take the square root of fraction, we can take the square root of the numerator and the square root of the denominator. So in the numerator, we get plus or minus the square root of b squared minus 4ac all over 2a, because the square root of 4a squared is 2a. And then we're still left with x plus b on 2a on the right. The only thing, hopefully you realize we need to get rid of, is this b on 2a. So we're going to subtract that from both sides. And so that looks like this. Subtract b on 2a from both sides, and then you're done. That's basically the quadratic formula. I've just moved the minus b over to the other side. Conveniently, they have the common denominators, right? 2a, 2a. So we can combine them because they've got common denominators. And so we get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And very nicely, that is our quadratic formula. And that's where it comes from. Essentially, we're completing the square on the general quadratic. Hopefully this diagram also helped. Okay, I thought it would be good if we could end with a problem, and you're welcome to let me know what you think about the problem in the comments. So by making reference to the quadratic formula, so everything we just spoke about, explain why the x-intercepts of a parabola are equidistant from the axis of symmetry. So if we look at an example here, we've got some parabola. The axis of symmetry, you might recall, is b on 2a. I want you to think about where that comes from based on the quadratic formula, and then see if you can explain with reference to the quadratic formula why these x-intercepts are equally far apart from the axis of symmetry. And let me know what you think. All right, hopefully you found that helpful. Yeah, feel free to reach out if you have any questions.